Hello, in this video we are going to see the numericals of the chapter sound. Before we start with the numericals, let us have a look at the formulas that we are going to use. So the first formula is speed is equal to frequency into wavelength. So velocity of sound is equal to frequency of sound into the wavelength of sound. The second one is for echo. So echo we use speed is equal to 2d over t. So if the observer is here, now he is saying something that is hitting a wall or an obstacle and returning back. So if this distance is d, the sound travels the distance of d and d, that is 2d, and it takes time t. So in this, there is a case that if you're looking at, in this, there is a case where you're talking about minimum distance. So when you're talking about minimum distance, then the time interval is 0.1 second. Now, why it is 0.1 second? Because after 0.1 second, the sound ceases to exist in the human brain. So therefore, if there is an interval of 0.1 second between two sounds, those two sounds are heard as distinct sound. Okay, so keeping that in mind, if we take if you take speed as equal to 2d over 0.1, then that corresponding distance is the shortest distance that you will hear an echo. Okay, so this is the shortest distance to hear an echo. Now there is a case where we use just speed is equal to distance upon time. That is happening when, say for example, this is the source of sound, this is an obstacle, and say the observer is here. Okay, so of course this person is producing sound, so the observer hears the sound directly. Okay, so that is speed is distance upon time. The observer will also hear the sound when this sound is reflecting back and coming. Okay, so in that case, if this is distance d1 and this is distance d2, then the total distance is d1 upon d2, and we use the formula speed is equal to distance upon time straight away. So with these formulas, we are going to start with the numericals. So let's have a look at the first numerical. This is the first numerical. Here we'll list down the information that is given. The wavelength of the wave produced on the surface of water is 20 centimeters. So I'm writing over here wavelength is 20 centimeter. We need that in meters, so I'm writing it as 0.2 meters. The wave velocity is 24 meter per second, so V is 24 meter per second. They are asking, number one, for the number of waves produced in 1 second. That is asking for frequency, because frequency is the number of oscillations or waves in 1 second. The second part is the time in which one wave is produced. So the time taken for one wave is called as time period. So T is equal to question mark. So I'm using the formula velocity is frequency into wavelength. So 24 is equal to F into 0.2. So F will be 24 upon 0.2. That is 240 over 2. So frequency is 120 hertz. So that's the first answer. For the second answer, we need time period. So time is 1 upon F. So that is 1 upon 120. Now how do we divide that? So for that I am taking 1000 in the numerator and 1000 in the denominator. So the 0 gets cancelled. 4 3s are 4 25s are. So that is 3 8s are 24. 8.33 into 10 to the power minus 3. So time period is 8.33 into 10 to the power minus 3 second. That can be written as milliseconds as well. So the answer, first one, frequency is 120 hertz, or you can write 120 per second. And the second answer is time period is 8.33 into 10 to the power minus 3 seconds, or it is 10 to the power or 8.33 milliseconds. Okay, let's go to the next question. Okay, so now we have the second question. This word is important in this. Minimum distance. To calculate the minimum distance. So that should tell you that time is equal to 0.1 second, and that is in air. And they have given the speed of sound also in air. So therefore, speed is equal to 350 meter per second. Time interval is 0.1 second, and they are asking us to calculate the distance. So S is equal to 2d over t, and in this formula, so we have 350 is equal to 2d upon 0.1. So 350 into 0.1 upon 2. So that will give you 35 upon 2. So this is 17.5 meters. Okay, so the person has to stand a least distance of 17.5 meters to hear an echo. Now we look at question number 3. In question number 3, again it is the same question, minimum distance, but this time it is inside water. So therefore, the speed varies. Sound travel much faster in water. So speed is equal to 1400 meter per second. Time interval is 0.1 second. So speed is 2d upon t. So this is 1400 2d and this is 0.1. So this is 0.1 upon 2. So 140 upon 2, that is 70 meters. So assuming the speed of sound in water to be 1400 meter per second, the minimum distance to hear an echo is 70 meters. Okay, let's go to the next question now. So in this question, the person is standing 25 meters from a wall. So this is a wall. A person is standing here, and this distance is 25 meters. The speed of sound is 350 meter per second. So if the sound produced by that person is hitting the wall and returning back, how much time is that going to take? So if I take speed is equal to 2d over t, so this is 350 is equal to 2d over this is and this has to be a distance which is given to be 25, and this is t. So t is 2 into 25 upon 350. This will go 14 times, so t is equal to 1 over 7. So this is 0.1428. So time interval is 0.143 seconds. So this is the answer to the first part of the question. The second part of the question says, will the man be able to hear a distinct echo? The answer to that question is yes, since the time interval, which is 0.143, is greater than 0.1 second. So 0.1 second is the minimum time interval for which the sound has to reflect and return back. Over here, it is returning back in time more than 0.1 second. So yes, a distinct echo will be heard. Now let's move to the next question. Okay, to the next question. We are using the similar logic, but now instead of sound wave, these are radio waves. So the radio waves does travel at the speed of light, that is 3 into 10 to the power 8. And here the aeroplane is at a distance of 300 kilometers. So the signal that goes from the station to the plane and returns back in what time? So we are using S is equal to 2d over t. So this is 3 into 10 to the power 8. That is 2 into 300 kilometers. So kilometer is 10 to the power 3, and this is time. So time is equal to 2, and this is 3 into 10 to the power 5, and this is 3 into 10 to the power 8. So that cancels. This will leave us with 3. That is 2 into 10 to the power 3. So the time interval taken will be 2 into 10 to the power minus 3 seconds. So it takes 2 milliseconds for the sound to go and return back from the station to the plane and back. Let's move to the next question. In this question again, distance is given to you 48 meters, and speed of sound is given to be 320 meter per second. You have to calculate the time in which echo will be heard. So S is equal to 2d over t. 320 is 2 into 48 upon t. So 2 into 48 upon 320. So this will be 16 into 20, 16 into 3. So this will be 2 ones are, 2 tens are, 3 over 10. So the time interval will be 0.3 seconds. So echo will be heard. We move to the next question now.